Hello and welcome to the Paleontology Lab. My name is Priscilla and I work in the education team at Melbourne Museum, and there are a number of others in the room, as well as Dr Erich, who I will introduce in just a moment. But we want to welcome, first of all, we have 6 schools attending across Victoria today, so we're very happy with that. We've got Ultima Primary School, Mordialloc, Spencer Street, Nagalock, Collinggan and District Primary School. I'm very sorry for my pronunciation, Hawkesdale and Royal Children's Hospital. So it's great to have you here, and this is one of our first sessions that we're doing like this. So we know, I can see lots of your tweets, so I'm going to be checking your questions coming this way. But first of all, well, this is what we're really here for, is Dr Erich Fitzgerald, our Senior Vertebrate Palaeontologist here at Museum Victoria.
Hi everyone.
Erich, I'm getting a lot of questions in about how long have you been doing your job and what do you do in your job?
So I'm a paleontologist. That means that I study fossils, and I've been doing this now for about a decade. That's 10 years. What do paleontologists do? Well, we study fossils. What are fossils? The remains of ancient life.
Right. So, Erich, you've got quite a number of things around us here now. So before we go to some questions, could you show the people streaming in what we have on the table here and around here?
So here at Museum Victoria in paleontology, we do science. So we do the science of paleontology, and that's research and studying of fossils from all over Victoria and even elsewhere around the globe. And that means fossils from Antarctica, Alaska, elsewhere in North America, even Saudi Arabia. So we're working on all kinds of fossils. Right here in front of me are actually some dinosaur bones. Here is part of a dinosaur leg bone, and this is the bone here. It looks a bit like a Mars bar or something that's been stuck into some grey goop. That grey goop is actually sandstone, and this fossil is about 100 to 120 million years old, and it's from the Cretaceous period. So that's a dinosaur. When we collect fossils like this in the field, and that's a process called field work, where we go and study the rock layers, the geology around Victoria. This particular one's from near Cape Otway. We then dig the fossils out, and this one's actually been cut out using a saw. You can see there where it's been cut using a rock saw. We bring the fossils back into the lab here at the museum, and then we actually have to try and extract and uncover that fossil bone from within that rock. You might be wondering how we do it. I'm going to show you. If we go this way, we have here a microscope that you see in all good science labs, and I'm going to use a tool here which we call an air scribe. You might be wondering, what on earth is that? The air scribe is actually a tiny miniaturized jackhammer. Hope you all know what a jackhammer is. It's used in breaking up rock and road work and construction. Well, we use a tiny version of that, a lot more precise, to break the rock away from around a fossil. And right here, I'm going to show you the leg bone of a dinosaur. This is the thigh bone of a plant-eating dinosaur called an ornithopod. Ornithopod means bird-footed, because their feet looked a bit like those of a bird. And I'll place this under the microscope, and hope this isn't too loud, I'll show you how we get the rock away from that bone grain by grain. It makes a bit of a noise, so hold on. And then carefully we chip away the rock from around that fossil. Being very, very careful not to hit the bone. Now, as you can imagine, this takes a long time. It can take years to extract some fossils from rock.
We've got quite a number of questions.
I bet.
So we're going to try and answer some.
We'll do our best.
Right, okay. How many fossils have you found from GT?
Wow, how many?
Yeah.
I don't know the exact number, but at least 100.
Great, that's good. What do you like about your job, from Ashy and Gracie?
What I like about it is, most importantly, discovery. You get to discover new things every day, and also we get to do all kinds of things. It's not just scientific research. We get to do things like this right now, talking to all of you, which is a lot of fun and really interesting.
How long has paleontology been going for?
Paleontology as a science is actually pretty young. It's only been around for about 200 to 300 years. And in Australia, it's only really got going as a science in the last 100 years.
Okay. How old were you when you started paleontology?
Well, I've been interested in fossils ever since I was 4 years old, and I know that because a family friend told me that on my 4th birthday, I told someone that one day I was going to be a paleontologist. Here I am. So I like to say that I have a case of dinosauritis that I'll probably never grow out of.
Great. Got more questions, but we might pause for some of those till are you taking us on a journey through the museum, through the labs?
Does everyone want to come on a tour through the behind the scenes, through the catacombs of the museum where we keep a lot of our fossils? If the answer is yes, I'll show you.
Right.
So everyone put on your time traveler's hats. We're going back in time. This way. Another paleontologist, they're everywhere. So we're going way back. So how far back? Well, the oldest fossils are not just 1 million, not just 10 million, not just hundreds of millions, but thousands of millions of years old. That's billions of years old. Now, I'm not going to show you fossils that old, but they're still pretty cool and really interesting in terms of how important they are to our understanding of paleontology. Okay, hold it right there. First stop is only 25 million years ago. I'm going to show you a fossil that is really important because it's a fossil that I studied. In fact, this was a totally new species to science that had never been seen before when I first started studying it in 2004. And this fossil is extraordinary. It made headlines around the globe, but you know what? It was found down near the town of Torquay on Victoria's surf coast, so that's not far from here, not far from many of you. And it was found not by a scientist, not even by an adult. This was found by a teenage boy who was down at the beach and stumbled across this find. And after 2 years of painstakingly scratching the rock from around the fossilized bone, this is what we found. This is a skull of an ancient whale, and I called it Janjucetus hunderi. Janjucetus means the whale from Jan Juk, and hunderi, which is the species name, is after the surname of the boy who found this fossil. And it is spectacular. These are the upper jaws. You can see the teeth here. This is the eye socket. Look at the size of its eyes, are huge. And right at the back here is this big space where there were muscles that were used to close the jaws with a lot of force. So this whale, even though it's pretty small by whale standards, more really the size of a dolphin, was a powerful predator. And so far, this is the only fossil known of Janjucetus, and it's only been found right here in Victoria. So major discoveries don't need to be made by professional scientists, and they don't need to be made in the really remote corners of the world like Antarctica or the Congo jungle. They're found right here in Victoria by people like you. Let's go a bit more recent in time. So now let's go forward in time. That was 25 million years ago. Now let's go to only 15 million years ago. Step this way. "15 million years ago, most of southern Victoria, from Portland in the west right across to Malakuta in Far East Gippsland today, was covered by a shallow tropical sea. And in those seas, lots of limestone was formed, the remains of ancient little marine critters, plankton, sea urchins, and shells. And what was also swimming in those seas were whales. This here, from here, all along, all the way back to here, is part of the lower jaw of a whale. It's 2 meters long. So this is about as long as that dinosaur I told you about was probably tall. And this whale died 15 million years ago, and its fossil was discovered at a limestone quarry. A quarry is kind of like a mine, but it doesn't have a roof. It's open to the air. A limestone quarry just near Geelong, here in Victoria. And there's something really cool about this fossil that I want to share with all of you, and that is it has some clues to how it died. So we're going to do a bit of paleontology CSI, crime scene investigation, and I want you to have a look here at something really interesting. If you have a close look here, there are these scratches, these big gouge marks all along this jaw of this whale. I wonder what these scratches are. If anyone can quickly suggest an idea for what might have caused these scratches or these marks, you could even call them injuries. There's a clue to this fossil whale.
We've got lots of wows and awesome. How about we go to a question?
Let's go to a question. You guys think about it.
Moment for some of their suggestions to come in. So, Eric, one of them is, do you want to bring back the dinosaurs? Maybe some DNA could be in the bones.
Well, here's some bad news for all of you fans of Jurassic Park and that want to see dinosaurs from the Cretaceous period walking around us today and maybe even chasing us, which would maybe not be so much fun. But anyway, bad news. DNA doesn't survive very long in the fossil record. In fact, the best we've been able to do in getting DNA out of fossils is only about 100, 200,000 years ago. Now, if you think about it, dinosaurs like Tyrannosaurus rex and Triceratops, they were alive 66 million years ago. So, unfortunately, it's not going to happen. But here's some good news. Even though we're not going to be able to bring back Tyrannosaurus rex and Triceratops, there are dinosaurs alive today. You guys are already well aware by now, I'm sure, that all the birds that you see around us, if you eat roast turkey at Christmas time, if you like chicken nuggets from McDonald's, even if you like quail or something like that to eat, apologies to the vegetarians, all of those birds are also dinosaurs. So when you next go and get your fried chicken, you're actually eating fried dinosaur. When you see an emu, you're looking at a dinosaur. When you see your pet cockatoo or your pet budgie, you're in fact keeping a dinosaur as a pet. You may sound weird, but it is absolutely correct, and we know that because of the science.
Right. Well, meanwhile, your fantastic responses have been coming in to Eric's question too. So some people have said DJ said another predator, Carly said dinosaurs, some people said attacked by sitting around, predator, what is another predator, someone who was hungry, a sharp-toothed predator, but one person, or two people, Charles and Clements, got it right.
Well, first of all, say great answers, everyone. Predator, for those that said predator, correct. The question is, which predator? And I think a couple of you may have got it right. Who got it right? It is
Charles and Clements said shark.
And it is. These are actually the bite marks of a shark. But not only that, because we can see in such detail the bite marks here on this jawbone, we can actually tell which species, exactly which kind of shark it was. Now, swimming around in the seas at that time, there were some pretty big sharks. Here's a tooth of one of the sharks that was swimming around when this whale was alive. But that's not a shark's tooth. That's a shark's tooth. This is a tooth of the extinct giant shark called Caracles megalodon, most commonly called megalodon. And this tooth was actually found at the same limestone quarry as this fossil whale jaw. And we know that from the patterns of these marks on the jaw that one day, 15 million years ago, a whale was happily swimming around doing its business in the seas that had flooded across southern Victoria, and it was unfortunate enough to have been attacked by a megalodon. So we actually have right here for you guys a snapshot from 15 million years ago. And that's one of the other things I love about paleontology, and that is it is really the closest thing we get to time traveling. I can show you right here a moment in time from 15 million years ago. I think that is absolutely astonishing. And there were many, many, many sharks that lived in Victoria for millions and millions of years. And those seas that covered Victoria only started to go back into the ocean. The landscape was rising slowly. That only started to happen about 5 million years ago. And at about 5 million years ago, one of my favourite fossil sites from not far from here in Melbourne occurred. And I'm going to show that to you right now. And this will be particularly significant to those students that might be tuning in from around Beaumaris, Cheltenham or Mordialloc. Because the most spectacular fossil site in all of Melbourne is Beaumaris. And I'll show you why. Shark heaven. Thousands and thousands and thousands of shark teeth have all been found there. And not just one kind. These here are all the teeth of one kind, but there were others, including our friend, the megalodon. So megalodon has even been found there at Beaumaris. And swimming in the seas of Beaumaris at that time was not only sharks, but whales, dolphins, seals, even dugongs, which today only occur in far northern Australia in tropical waters. So this is a really rich fossil site where we have thousands and thousands of fossils. And maybe one of you from anywhere in Victoria, if you're visiting Melbourne, you could go to Beaumaris and if you're really lucky, find yourself a fossil shark's tooth. Do any of you have any questions about fossils or about fossils from Beaumaris, sharks or whales?
I'm sure they'll come in, but we have some other ones. This is a good question. Somebody said, didn't the flying dinosaurs evolve into birds?
Well, the thing is that the dinosaurs that were flying are what we today call birds. I think you might be referring to fossils called pterosaurs. Do you want to see fossils of some pterosaurs? Let's go this way. So pterosaurs are another group of reptiles that actually didn't evolve into birds, and in fact aren't actually dinosaurs. Pterosaurs are close relatives of dinosaurs. You can think of them almost as cousins. Whoa. Well, I don't have pterosaurs, but I do have something else. And it's something that lived at the time of pterosaurs. Now I want to show you a tooth, and it's a tooth of a very famous dinosaur. If you're wondering which kind of dinosaur, it's a meat eater. It was in the Jurassic Park films. It was about 12 meters long, and it weighed as much as a bull African elephant. And that is Tyrannosaurus rex. I'm holding a tooth of Tyrannosaurus rex. This is just a small one. To give you an idea of how large the teeth of Tyrannosaurus rex are, I'll show you a replica, and that is a model of a tooth of Tyrannosaurus rex. And this is what a larger tooth of Tyrannosaurus rex looked like. So the bit that was actually poking out of the jaws or sticking above the bone is this here, and that's called the crown. The same way that in your jaws are the crowns of your teeth. And all of this part of the tooth is the root that was embedded in the gum of the jaw. So T-Rex had big teeth, but maybe not quite as big as most people imagine. That's about as big as they got, what was sticking out of the jaws.
Great. Okay, while Eric's just putting that away, we have there's lots of good questions here, but one of them I'm going to go to is, why are the bones so white? I thought they were dirty and dusty looking.
That's a really good question. Bones can sometimes look amazingly fresh. I'm going to show you fossils from one site, and these are fossils that are only about 100,000 years old. But they look amazingly clean. These are fossils from a site about halfway between Warrnambool and Hamilton, near the town of Mennonite. And here we have extraordinary fossils. Here's one. This is a leg bone of an extinct kangaroo. This is actually the thigh bone. And this there is the ball that fit into the socket of its hips. In fact, it looks a bit like your hip bone or thigh bone. And these fossils are really well preserved. If you look at the teeth, you'll see they're stained black. And they do look a little bit dirty, but fossils can be a variety of colors. In fact, some fossil bones look exactly, almost exactly like the modern bones of animals and are barely stained a different colour. I'll show you some other cool fossils from here. Here's the jaw of a kangaroo from that site. You can see these are the teeth that it used to munch up grass. And here is actually what most fossil bones look like. Unfortunately, are broken up, and they don't survive as intact bones in the fossil record. Most that we find are just shards of bone like this. And in fact, these are so light that you wouldn't even think they were fossilized if they weren't stained this brown color. But they are indeed fossils, maybe 100,000 years old.
Great. All right, we only have a few minutes to go, and I've gone back to an earlier question,
Sure.
which was from the Royal Children's Hospital Education Institute.
Mm-hmm.
And they asked you, Dr. Erich, what has been the most memorable part about your career as a paleontologist?
Wow. Well, probably the most memorable part was when I was doing some field work in Western Victoria, Nelson Bay, near the town of Portland. And we were down on site there, working in one particular area, and it was memorable because we were digging away in the rock, and then I found the tooth of an extinct kangaroo that had never been found at that site before. And it was really important because up until that time, that kind of kangaroo hadn't thought to have been around at that time, that far back in time, about 1 million years ago. So that was the first discovery of that kind of kangaroo that far back in time. And that thrill of digging it out of the rock and realizing that you might have something that has never been discovered before from that time and place is really a massive adrenaline rush. And so I encourage all of you to get out there, get interested in science, get interested in fossils, and see what you might find.
Great. Oh my goodness, there's so many more fantastic questions.
Wow.
We might just take one more, which I thought was also relevant. Somebody asked you, what is the oldest fossil?
Wow. The oldest fossils are probably from Western Australia, and they are the fossils of a tiny little bacteria-like organism, just one tiny little cell that you need a very powerful microscope to look at. And they're about 2.5 billion years old. That's 2,500 million years old. To give you some idea, that's not too long after the first water appeared on Earth. So we're talking way back. And in fact, if we went back to that time ourselves, and if we didn't have a special astronaut-like suit, we'd die because the atmosphere of Earth was actually like an alien planet for us. So going back in time that far is actually a lot like visiting a totally different planet.
Great. All right. Thank you very much, everyone, for participating in our very first streaming class. I hope this has been very good from your end, and we'd love to hear your feedback through today's meet to know how you experienced it. Dr. Erich Fitzgerald, thank you so much for participating.
Thank you. It was a great fun, guys. Good to speak to you all.
Yeah, and good luck with all your science studies.